Hello, everyone. Good morning, good afternoon, good evening, depending on your time zone and wherever you are listening from. My name is Austine Unuriode, and I'm a graduate student at Austine Peay State University here in USA, and I'm studying computer science and quantitative method. Our topic of discussion today is the integration of artificial intelligence into database management system. And this is a review that was done by myself and my other colleagues, which their names are listed here. Our discussion today will be guided by this agenda. Firstly, we'll deal with the introduction, then we'll move to basic definitions, then an overview of AIDB itself, then we'll move to the literature review, which is the core part of this review. And this is basically centered around progress and improvements that has been done so far in terms of an ability to be able to integrate data AI into database management system. And I would quickly like to say that this is more of a foundational review in the sense that what we basically did was to review literatures of past researchers and academians on the ideas and the progress that have been made so far in terms of being able to integrate AI into database management system. And we are going to definitely use this as a foundation going forward to be able to write other reviews or do more research in this line, because at the end of this presentation, we'll discover that there are less work that has been done and there are more work to be done to be able to integrate AI into DBs. And then the last few chapters of my presentation would be recent outlook of AIDB. Then we'll quickly talk about the future of AI and DB integration. Then we'll conclude. And if at the end of the presentation there are questions, I would be so pleased to take them. Now let's proceed. There is a saying that goes now that data is the new oil. And the reason this is, in my opinion, is because of the fact that there are huge potentials and huge benefits of data. Anybody that has data these days basically has so much information embedded in it, right? And being able to store that data in a particular location and being able to retrieve it is the essence of having a database and a database management system. And where AI comes into that category is that for us to be able to access those data, interact with those database management system in a way beyond the traditional method is what we are trying to achieve here. And that's where the AI comes into play. Then moving on, we'll quickly have some definitions of some of the key terms that were used throughout the course of this presentation and in the main paper itself. Like I rightly said, data is the new oil, but data on its own really doesn't have a form or a meaning unless a meaning is given to it or a context is given to it. Like what you can see on the screen, I have 0, 20, 46, and 9. This doesn't really tell you anything, but it refers to as data. But when you give it a context, it becomes very insightful. And the meaning we get from this is basically what you attribute to it, right? Then the next thing we'd have to define is a database itself. And this is a very foundational definition of database, which is it's a collection of organized data logically related. Yes, for something to be in a particular location, right, there must be a relationship between all of them. Then the schema is basically how data are organized in a relational database. I usually try to refer to this as more of, if looking at your normal table, is more of a column header, right? And the type of schemas that we have are conceptual schema, logical schema, and physical schema. Then the few last definitions that we have are database application. This is a system that help us to translate those data or interact with the database and translate the data we have there into insights that makes meaning to human being. And basically, this is the backbone of the AI-DB integration itself by providing a foundational infrastructure to store and manage and retrieve data. Then moving on, artificial intelligence itself, I have a definition here that I like so much. It says that it refers to as a machine that can replicate human intelligence in a way to perform tasks and can repeatedly improve themselves. Basically, this sums up the entire definition of AI itself. And if we can introduce these techniques or this technology into a database, it then means that we'll get to a stage where a database would be able to do some queries and a lot of things by itself, and human effort will definitely be reduced. Then integration of AI and DB itself, which basically referred to as the process of combining both technologies to be able to handle a more advanced analytics and be able to produce a very good insights. Then moving on, an overview of the entire integration itself. And this is basically sum up the reason why we made an attempt to review this paper itself. And that's because for us to be able to improve the power of analytics, the power of data analytics, and being able to deploy informations and insights to whatever data or management system that we are trying to interact with at that point in time. The last statement simply says that AI-DB integration review strive as a compass in this terrain, pointing to the ways to a future where data is empowered to improve the very foundation of our data, our decision-making process, rather than just being managed, right? So it basically says that it has to be a step further, right? Rather than the traditional system, just managing data, storing them, we want to be able to do it much better, and using AI would make the whole process a bit faster and more efficient. Now, literature review. This sums up the progress that has been made so far as regards this topic. The very first one is IDI. The second one is Learnable database. The third one is smart query. And then we have autonomous database. This is not an exhaustive list, but we decided to restrict ourselves to this. Like I said before, we are trying to create a foundation for more work that we intend to do when it comes to this topic. Now, the very first one, explaining all of this is IDI. IDI is an interactive and compatible user interface that is intended to provide efficient access to database in several remote database management systems that permits structured query language. And what is unique about this is it has its own language that also interacts with the traditional language, which is SQL that we all know. Again, it's a cache-based interface that is designed specifically because of an attempt to integrate AI into database management system. Now, this is the pictorial framework or structure of how IDI looks like, with various components and features. And all of this, some of these key details will be explained in subsequent slide. Now, the very first one we have as the main component of the framework of IDI is the schema manager. From what I have here, the information of a declared DB is determined by the schema manager. it processes DB declaration, basically. And the second point is the schema manager also provide information for individual database relation to a query manager. Then the next key framework we have is DBMS connection manager itself. This basically creates the ability for the IDI to be able to connect to database remotely. And the third part of the framework is the query manager. The query manager holds and manages the language query itself and its results. If the query is executed successfully, it also returns a generator with that's the definition of a generator there. Then moving on with the third part of the framework of an IDI is the cache manager, which is responsible for managing the query results. This includes identifying the language query for which the result exists and catching queries results. Then for us to be able to use the cache manager correctly and efficiently, we have the update tracker, which basically was introduced because of some of the problems that were encountered by the cache manager not being able to update itself immediately, because the essence of the entire integration itself is for speed, efficiency, and better performance. So if this was happening, definitely we have to introduce something else that would be able to correct that. And that's why we have the updated tracker. Now, what are some of the advantages and features of IDI? The very first one is that provision of seamless and efficient access to remote database. So it helps to connect to database, remote database seamlessly. And the second notable features that we have here is ease of access to, it has the ability to connect to multiple database and makes all of the database active at the same time. This is what is currently not done except in when it comes to cloud technology. But talking about the traditional relational database management system, this currently does not have this. Then the last key point there is provision of a wide range of interference between different DBs with little or no modification. And the beautiful part of this whole thing is that it still interacts with the SQL language, which is still being used to communicate with the DBMS itself. Now, the second notable progress that has been made, according to researchers and academia, is the Learnable DB. And this is basically the summary of machine learning and how machine learning technology has been used to, or how it will be used to improve the DBs itself. And one of the key feature is that it makes DB more intelligent and adaptive, having the ability to instinctively improve according to historical data or records and present query overload. Second point is having the ability to depict various features of data with machine learning and then pick the most efficient way. And I think this sums up the whole idea of AI, right? It learns from a lot of information that you fed it with over time, and it makes decision on its own that's more efficient and performance driven. Now, under Learnable DB, as a key improvement or initiative under this topic, we have some key contributions, which is parameter configuration, database management storage, database query optimization, and query interface. We'll quickly talk about all of this in the subsequent chapters. Configuration of database parameter. Again, Learnable DB configuration aims to utilize AI technology to automate database configuration and functionality and improve performance and efficiency. Some of the ways this has been done as follows. Analysis of workload. Because of the intelligence of the AI, it's able to analyze the workload that is present on a database management system at a particular time and decide on how to approach them differently. Then another key point there is turning plan. We have SQL rewriter and we have database partition. So it's automatically partition the database memory system itself to be able to provide optimal results at every point in time. Then the second point is database management storage. Data is more valuable than ever before, and database has proven to be more common ways to manage and store data. The storage manager equipped AI features to model analytics to speed up data retrieval and analysis. Then the third point here is database query optimizer. Definitely applying ML to queries definitely would optimize the query and increase the efficiency of how query runs. And since machine learning learns from historical data, definitely all of the queries that has been fed to the system thus far, it will definitely learn a pattern from it, and over time learns to make some decision on its own. The fourth point is query interface, and this would also be discussed in subsequent slide more. This is all about a query interface whereby a query would have to be the manner in which we currently interact with the traditional database would have to be improved, whereby an idea that was proposed would be to we have a situation where would a natural language processing idea would have to be used in query interface, where you don't have to write queries, you don't have to be a programmer. All you need to do is to speak and the computer understand and turns that into query and relates it with whatever you are trying to do at that point in time. So just like I've tried to explain, smart query basically is being able to interact with database in a human-like format, where natural language is used to interact with a database. I have a part of the information on this slide that I highlighted, which says that part of the idea is to have a natural language intelligent database which permits users to formulate queries in a natural language, accessing information stored in database. This is the whole idea of a smart query. And some of the ways we think that this might work is first, the smart query employ speech recognition techniques to convert spoken language input into text. Yeah, if that is done, then it makes life way easier. Then a semantic matching techniques is employed in converting natural language query to SQL language. Then the last one will be complemented by using a dictionary and a set of production rules. The dictionary consists of semantic sets for column and table. Then the last point, which is the advancement or the idea behind integration of AI into DB, is the autonomous database. This is, to sum this up, basically, is to have a database that can basically work on its own, so without human interference. We currently have some of these technologies in terms of cloud, but in normal traditional database, we really don't have it yet. And in terms of cloud, where we've had it, an example here is the Oracle 1.8c, which is the limited step to autonomous database. And some of the key feature is that no human labor, database automatically upgrade, patches, and turn itself while running, automate security updates with no downtime and required, no human error, SLA, and the list just continue, right? So this is the same idea that is autonomous database would do when this whole idea is definitely transferred into the traditional database that we currently have. Now, moving on, recent outlook of AI DB introduction. This is more like a progress report. The performance of database is changing because AI-powered query optimization. Utilizing machine learning algorithm, database may examine query trend and suggest the best execution strategy. Some of these things I have mentioned it in this previous slide. The speed and responsiveness of database are increased overall thanks to the automation, significant reduction in query processing time. And another outlook we have here is automated query tweaking. Database can autonomously identify performance bottleneck and suggest real-time improvements by utilizing machine learning and algorithm. All of this is currently at the infancy stage, but I think with the way technology is moving so fast, in a few years from now, all of this would be fully integrated into the traditional database, and life will be made easier for a lot of us that on a day-to-day basis have to interact with this database. Now, what are the futures, the future that we see in terms of AI and database integration? Now we try to break all of this thing down into the progress that has been made so far, just to foresee the future of where these ideas that are currently we currently have would go to in few years to come. So we are thinking that in terms of IDI, AI-driven interface will become more user-friendly. That's what we want, obviously. Intuitively enabling natural language interaction with databases and increasing non-technical user ability to access and manipulate data. If it gets to a point where you don't have to be a programmer anymore to be able to write a query, it's so beautiful, and it makes life very easy for everyone. Then the second point is Learnable DB. We think that DB will become more adaptive because of user query and user trend, optimizing data organization, indexing on their own, and enhancing query performance. Definitely, machine learning will play a key role in the development of the integration of AI into DB. Then the third one is smart query. Like I said before, the idea behind all of these particular points is for us to be able to convert text to convert what to text and then to query. AI algorithm will improve query optimization, provide more effective and context-aware query processing, result in faster insight and less query complexity. Then the last point, which we think that is the future, is that autonomous database. In the future, we would see fully autonomous database that can self-monitor, self-tune, self-repair, minimize downtime and manual database maintenance activities, increase reliability and lowering operating costs. In conclusion, in this review, we try as much as possible to review the various avenues of development in the convergence of AI and DB system. We try to shed light on some of the researches and idea of authors in the past, being that we felt that these ideas were relevant and if pursued, would make the integration of AI into DB seamless and improve a whole lot of performance in that aspect. Again, it is still very much an open, we think it's still very much an open topic for both researchers and academia, because there is really no concrete thing that has been done yet, like I said, except when it comes to cloud technology. And lastly, for seamless integration to happen, this is just a quote, there must be an equivalent of the data model deployed in database and representation of knowledge in AI system. This is all about this presentation. I hope I was able to communicate some ideas and put some thoughts in our mind regarding the integration and the progress that has been made so far in terms of trying to integrate artificial intelligence into database management.